So example 2 here. Example 2, we don't have any information to graph, but we have a nice fancy little equation in which we can calculate information. Okay? So example 2a, graph the following equations, state whether they are linear or not, and explain your answer. So with equations, when we're getting a table of values to plot the equation, so at this point, the only way we know how to plot equations is to plot some information from a table of values. If we're not given a table of values, we have to create a table of values. Now remember that we want our graph of our equation, we want the graph of our equation to be representative of this coordinate axis set. Okay, so we want it to be representative here. We don't want to just end up with some kind of graph that ends up over here or over here, because it's not representative necessarily of what's happening over here. The easiest way to show how a relation is spread out over a coordinate plane is when you choose values to do your calculations, you choose some that are negative and some that are positive. And I always choose 0 because it's a nice easy calculation. And I'll show you what I mean here. So when I normally start a table, I'm going to start a table saying, okay, if I have this table of values that I need to fill in with this equation, y is equal to 2x plus 1, y is equal to 2x plus 1. Just write it there so I can see it. I'm going to start by saying, well, I want to see what happens in the negative portion of the graph for x. I want to see what happens in the positive portion of graph for x, and I also want to use 0 because 0 is a nice easy calculation. So my table, I begin by saying negative 2, negative 1, 0, 1, 2, well, and maybe 3, seeing as how I have space. So that means I'm going to choose those values for x and calculate the values for y. And how do we do that? Well, let me do this so I don't have, there we go. So first I start with my equation. Y is equal to 2x minus 1, or plus 1. Y is equal to 2x plus 1. Now in a perfect world, I wouldn't be doing this across the page, I'd be doing this down a page just because that's how I roll. And you should get used to doing math work up and down as opposed to left and right. The next thing I would do is I would substitute in this negative 2 value. I would substitute in this negative 2 value in for x. So now my equation will look like this, equals 2 times negative 2 plus 1. So I've just simply substituted the negative 2 in for x. Then I start to calculate. Well, 2 times negative 2 is negative 4, and negative 4 plus 1, negative 4 plus 1 is negative 3. This is the y value that is associated with the x value of negative 2. So 3 goes here. And I continually do those calculations. Y is equal to 2x plus 1, substitute in negative 1, calculate, and there's my y value. Negative, whoops. Oh yeah, negative 1. And then I do that again for 0. Y is equal to 2x plus 1 is equal to 2 times 0 plus 1, which is equal to 0 plus 1, which is equal to 1, 1. So you get the idea that you substitute and calculate. Now, showing all these steps and all this work for a simple equation like this, yes, a little bit monotonous and tedious, but you need to get into the habit of doing this process so that you can know what to do when you come across a more complicated equation to deal with. Okay. So if I just do these rest of these very quickly, 1, 2, and 3, y is equal to 2x plus 1, substituting in 1 plus 1 is equal to 2 plus 1, which is equal to 3. 3 goes here. Next one was 2, y is equal to 2x plus 1 is equal to 2 times 2 plus 1, which is equal to 4 plus 1, which is equal to 5. 5, y is equal to 2x plus 1 is equal to 2 times 3 plus 1, which is equal to 6 plus 1, which is equal to 7. And now I have a table of values that I could very quickly graph. Okay. Well, hopefully very quickly. I'm sure you've had some practice at graphing. So -2 and +3. -2, 3 is a point right here. Oh, sorry. My apologies. That's a -3. -3. Because this is negative. My apologies. So let's get rid of that point because that's not in the right place. We have -2, -3. That's down here. Then we have -1, -1, which is right here. We have 0 and 1. We have 1 and 3. We have 2 and 5. And we have 3 and 7. So there are my points. Now with straight up equations like this, you can draw a line that connects those points. Okay? So normally we would just say, okay, well, let's now draw a line that we can maybe get through all of those points. Pretty close. Best I can do with what I've got. Okay? So there is our equation with a table of values, points plotted, line drawn. Is this linear or not? Well, clearly by looking at this line, it's linear. By looking at this table of values, we have a constant change of 1. Here we have a constant change of 2. Either way, it's constant all the way down and through. So because these are both constant, it's going to be linear. Okay. Now, just as an extra, what's the domain and range of this equation? Pausing to let you do it. Domain, remember, is all our x values. In this case, the domain of this is x can be all real numbers. The range, the range would be y can be all real numbers. That's example I for example 2. Now let's quickly do double I or II for example 2. So here we have the equation y is equal to x squared minus 5. And again, you'd go through this whole entire process. Y is equal to x squared minus 5. Choose some points. Let's say -2, -1, 0, 1, and 2. Substitute into your equation. Y is equal to x squared minus 5, which is equal to -2 squared minus 5. Be careful when you calculate -2 squared on your calculator. It is actually 4. Whoops, not minus 4, it's minus 5. This gives me -1. 2, 4, 5, -1. Do it again. Y is equal to x squared minus 5. -1 is my value. Squared minus 5, which is 1 minus 5, which is -4. Zero. Y is equal to 0. Oh, no, it's jumping ahead. X squared minus 5, which is equal to 0 minus 5, which is equal to -5. Oops, I didn't do the substitution. So substitute in is going to give me 0 squared minus 5. Now that's 0 minus 5, -5. Y is equal to x squared minus 5, which is equal to 1 squared minus 5, which is equal to 1 minus 5, which is equal to -4. -4. Y is equal to x squared minus 5, which is equal to which is 2 squared minus 5, which is equal to 4 minus 5, which is equal to -1. -1, and then we can plot those points. You could do a sixth one there if you want, but I'm trying to get this done fairly quickly. So I plot those points. -2, whoops. -2, -1, -1, -4, 0, -5, 1, -4, 2, -1. And you can see straight away that we now know that this is not linear. So up there it was linear, here it's not linear. Because it's not a straight line, when we do graph this, we actually join these points, creating something that looks maybe like this. Okay, it's called a parabola. It's not linear because we can't get a straight line out of those points. And if we look at our table of values here, yes, this is constant by a value of 1, but over here, this is not constant. It changes by more than values that are constant between each. So it's a value of 3 here, a value of 3 here from here to here, a value of 1 from here to here, a value of 1 from here to here, and a value of 3 from here to here, and if you went up, it would even be bigger. Okay, so not linear, mainly by looking straight at the points on the line. But then you could also do digest the table of values to see if it was linear or not linear.